Hello everyone, very good afternoon to all of you. Myself Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today I am going to discuss from Model 2 the long answer type questions. I want to discuss the solution of long answer type question from Module 2. So these questions give higher marks to the student in exam. So I request to you student that these questions understand thoroughly and step by step seriously you listen the solution. And I want to discuss the solution of these questions step by step clearly in detail. First of all, I want to suggest two references of textbooks which are very important for engineering student, engineering courses, engineering mathematics. So the first textbook, in first textbooks, the name of the authors are N.P. Wali and Dr. Manish Goyal. Publications, Lakshmi Publication Private Limited. And second textbook, the name of the author H.K. Das and Dr. Rama Verma. Publications, S. Chand and Company Private Limited. These two books are very important for engineering mathematics for second semester. Now, in part B of module second, I want to solve long answer type questions, which are very important questions. So question 1, I am discussing the solution of question 1 in this lecture in detail. Solve the differential equation d square plus 3d plus 2 into y equal to 2 cos 2x plus 3 plus 2e to the power x plus x square. The module 2 topic, name of the topic is linear differential equation of higher order with constant coefficient. The name of the topic in module 2 is linear differential equations with higher order with constant coefficient. So basically in these equations, one is dependent variable and one is independent variable. And there are numbers and constants are multiplied in each term with differential coefficients. In each term of the differential equation to the left hand side, multiply either constants or numbers. Numbers are also constant. And in right hand side, there is some function of x. Okay. So these equations are known as a linear differential equation of higher order with constant coefficient. Constant coefficient means number, coefficient means multiply. Numbers are multiply in left hand side in each derivative. Okay, but right hand side is there some function of x. So what is the procedure to solve the question? What is the method we will apply here to solve the question? So in this question, we apply y is equal to y is dependent variable. So y equal to CF plus PI. CF means complementary function and PI means particular integral. First of all, we find out the complementary function of the given differential equation, and second part we will find the particular integral of the given differential equation. Both solution after finding, we will adding. After adding, we get the complete solution. So here, this differential equation is known as a linear differential equation of second order with constant coefficient. So here, the solution. D square plus 3D and plus 2 into y is equal to 2 cos 2x plus 3 and plus 2e to the power x plus x cube x square. This is the question, and this question is equation 1. Now solution of 1 is y is equal to CF plus PI. CF plus PI. Y is equal to CF. Y is equal to CF means complementary function. Complementary function. And PI plus PI is particular integral. Okay. So we will find out in this question complementary function and particular integral. After adding complementary function and particular integral, we get complete solution. This is equation 2. Is our answer. So in part 1, we will find the complementary function, and in part 2, we will find the particular integral. So now here d square plus 3d and plus 2 into y is equal to 2 cos 2x plus 3, 2 cos 2x plus 3 and plus 2e to the power x plus x square. This is equation 1. First of all, first part A, we apply here method CF plus PI method. CF plus PI method. Name of the method is CF plus PI. So in part A, we will find complementary function. Complementary function. Okay. In part A, we shall find a complementary function. So to find complementary function, complementary function putting right hand side equal to 0. Putting RHS is equal to 0 in question in equation 1. Then we get, okay, first of all, we find out the complementary function of the given question. In a linear differential equation of higher order with constant coefficient. So how we can find the particular complementary function? To find complementary function, putting RHS equal to 0. If RHS is given, in right hand side is given some function of x. So we are taking in right hand side function is q, that is known as a q function. Q is some function of x. So putting right hand side equal to 0. First of all, we are putting in the question 1, in the given question, in equation 1, RHS equal to 0. Then we get, so here d square plus 3d and plus 2 into y is equal to 0. This equation 3. In this equation 3, we have taken right hand side as a 0. Without taking right hand side 0, we cannot find complementary function. Now let us consider that y is equal to e to the power mx is a solution of equation 3, and this solution verify to 3. Here let us consider that y equal to e to the power mx is a solution of equation 3, and this solution verify to 3. After verifying we get d square plus 3d and plus 2 e to the power mx equal to 0. Putting y equal to here e to the power mx, because y is dependent variable and y is some function of x. So I am considering here y equal to e to the power mx is some solution of this differential equation 3. Then this solution is, this is the function is the solution of equation 3. Then this solution verify to equation 3. After verifying means putting y equal to e to the power mx in equation 3. Then we get equation this 4. Now here multiply e to the power mx in this bracket. So here d square e to the power mx plus 3d e to the power mx and plus 2 e to the power mx equal to 0. Here d equal to d over dx, differential with respect to x d. D is the differentiation operator with respect to x, capital D. Capital D represented by differentiation with respect to x. So here 2 times differential of e to the power mx. d2 over dx2 of e to the power mx and plus d over dx of e to the power mx and plus 2 e to the power mx equal to 0. Now 2 times differential of this we get here m square e to the power mx plus 3 e to the power mx 3m e to the power mx and plus 2 e to the power mx equal to 0. After verifying, we get this. Finally, m square plus 3m and plus 2 e to the power mx, this equal to 0. So here e to the power mx is a solution. This equation number 4, 5. This is 5 equation. Here e to the power mx is a solution of 3. So e to the power mx is not 0. Is not 0. In equation 5. Not 0 in equation 5. Okay. Because there is a formula a into b equal to 0. Either a 0 or b 0. Okay. So then we can say d square plus 3m m square plus 3m plus 2 equal to 0. So m square plus 3m plus 2 equal to 0 is an auxiliary form of 3. We will get this auxiliary form direct putting d equal to m and removing y from 3. Here we have discussed about the formula in detail, how we can find an auxiliary form. But in our question, we can get directly an auxiliary form after putting d equal to m and removing y. Y is a function. Function is never 0. We want to find the value of y. So y is never 0. So putting d equal to m. How we can putting d equal to m? I have given here procedure. E to the power mx is a solution. After putting right hand side equal to 0 in our question and left hand side equation this equal to 0, then there is e to the power mx is some solution of the equation number 3 and that solution verify to equation 3. Then function is not never 0. So other results equal to 0. Other results is m square plus 3m plus 2 equal to 0. And e to the power mx is in multiply. So e to the power mx is never 0. Here we apply formula a dot b equal to 0. In any question, a dot b equal to 0, it means either a0 or b0. a0 then b is not 0 and b0 then a is not 0. So here we find in equation 5 m square plus 3m plus 2 multiply by e to the power mx equal to 0. So here we can say that either e to the power mx equal to 0 or m square plus 3m plus 2 equal to 0. But e to the power mx is our solution. So solution is never 0. Then we can say that m square plus 3m plus 2 equal to 0. So here we get m square plus 3m plus 2 equal to 0. This is equation 6. Now factorizing this. Factorizing this, m square plus 2m plus m plus 2 equal to 0. So m common, m plus 2 plus 1 common, m plus 2 equal to 0. So m plus 2 is common and m plus 1 this equal to 0. Then putting m equal to here minus 2 and minus 1. Here roots of an auxiliary form, roots are of an auxiliary form are different. So we apply formula for CF for different roots. So formula is CF is equal to C1 e to the power m1x plus C2 e to the power m2x. This is formula. But we know that from equation 6, m1 is minus 2, m2 is minus 1. Putting these values, this equation 7, putting these values in 7, putting in equation 7, then CF is C1 e to the power minus 2x plus C2 e to the power minus x. So now we find here CF complementary function. This equal to C1 e to the power minus 2x and plus C2 e to the power minus x. This is solution 8. This is complete CF we have find here. Now next part B, finding PI, particular integral. So here PI equal to, formula of PI is 1 upon FD into Q. Q is the function of right hand side. Q is the given function in the question. Q is the function given in right hand side of question. Right hand side of question. Right hand side of the question. Okay. So now here putting FD. FD means function in D. So that is D square plus 3D and plus 2 into 2 cos 2x plus 3 plus 2e to the power x plus x square. This function is giving. So now breaking this result here, 1 upon d square plus 3d plus 2 into 2 cos 2x plus 3 and plus d square plus 3d plus 2 into 2e to the power x plus 1 upon d square plus 3d plus 2 into x square. This is equation number 9. Okay. Here multiply this function to each function. This derivative in each function. There are three functions. Function 1, function 2, function 3. Function 1, function 2, function 3. There are three functions in our queue, in our question right hand side. So we find out the pi of each function separately. So here I am writing here I1 1 upon d square plus 3d plus 2 into 2 cos 2x plus 3. This equation 10. And I2 1 upon d square plus 3d plus 2 into 2e to the power x. This equation 11. I3 this equal to 1 upon d square plus 3d plus 2 and into x square. This is the 12. So there are three particular integrals because there are three functions in our question. So each function we will find separately the particular integral. So now and after adding then we get complete pi. Pi of I1, pi of I2, pi of I3. So now here I1 pi 1 upon d square plus 3d and plus 2 into 2 cos 2x plus 3. Here is trigonometrical function and here is cos. There are only two functions involved in particular integral, sine and cos. So here cos ax plus b is constant, 2x plus 3. So here multiply with x is 2. So putting d square equal to minus 2 square in this denominator, putting d square equal to minus 2 square. Only d square equal to minus 2 square. Then we get here 1 upon minus 2 square and plus 3d plus 2. Here 2 cos 2x plus 3. Okay. Now this is 1 upon 3d minus 4 plus 2. Minus 4 and plus 2. 2 cos 2x plus 3. So this is I1 equal to 1 upon 3d plus 2. Multiplies conjugate 3d minus 2 and 3d minus 2. Multiply conjugate bracket of this. This is the conjugate of this. So multiply by this bracket in numerator and denominator. Here is 2 cos 2x plus 3. So 3d minus 2 and here is a plus b, a minus b. So here 9d square minus 4. So 2 cos 2x plus 3. So again putting d square equal to minus 2 square. Again. So this result is, here multiply this 3d minus 2 and upon 9 into minus 2 square and minus 4. This is I1. This is I1. So now I1 equal to, and the function multiply in bracket. This function multiply in this bracket. So we get here 3d d, and in bracket 2 cos 2x plus 3, 3d, and minus 2 into 2 cos 2x plus 3, and upon is 2 2 ja 4, 9 into minus 4 and minus 4. So I1 is equal to this differentiate with respect to x. So cos, differential of cos is minus sine. Differential of cos x, d over dx of cos x is minus sine x. So this formula we apply here. Here 2, 3, 2 ja, 3, 4 ja 12. So here is minus sine and 12. 2 is this multiply. Here multiply formula of cos 2x. Cos 2x. So minus sine 2x minus sine 2x and into 2 minus 2 sine 2x cos 2x. dy dx of cos 2x is minus 2 sine 2x. So we apply here minus 2 sine 2x. So we apply here one time formula is 3 2 ja 6 into minus 2 and sine 2x plus 3. And here is minus 4 cos 2x plus 3 upon minus 36 and minus 4. So minus is common, numerator is minus common, and here minus 4 is common, and denominator 4 is common minus. So here 4 common means 3. 3 sine 2x plus 3 and plus cos 2x plus 3 upon there is 40. 4 is common, so here is 10. Final answer, this cancel to this. Final answer, I1 is equal to, this is Pi, I1 is equal to 3 sine 2x plus 3 and plus cos 2x plus 3 and upon 10. This is answer. This is I1. We find only I1. So I1 is equation 12, this 13. So this is 13. Next, I2. I2 is Pi. Pi is 1 upon d square plus 3d and plus 2 into 2e to the power x. Formula of Pi is 1 upon fd into q. This is the second function in our question. Value of q. Second value of q. So this result here e to the power ax. If q is e to the power ax, then putting d equal to a. Here is q is e to the power x. So a is 1. Putting d equal to 1. So we write here pi I2 equal to pi and this upon d. 1 ka square plus 3 into 1 and plus 2 into 2e to the power x. So this result is 1 upon 6, 1 plus 3 and plus 2 into t to the power x. This equal to 1 upon 6 2e to the power x. 2 cancel. So your answer is 1 upon 3 e to the power x. This is the pi of I2. Okay. This equation 14. Okay. Now last. I3 is equal to pi 1 upon 3d plus d square plus 3d and plus 2 into x square. This is last particular integral. This is the third function in our question. So how we can find the pi here? Here is x square. So here minimum power of d in denominator, minimum power of d in denominator. Taking common. Okay. So minimum power is 1 upon 2. 1 upon 2 is taking common. And here is 1 plus d square plus 3d upon 2 whole to the power minus 1. This taking in numerator. So x square. Now open by binomial. 1 upon 2. This opening by binomial. 1 plus d square plus 3d and y2 plus d square plus 3d का whole square. Y alternate sign is there. Okay. So here is y4 and this plus up to goes infinity and into x square. We are taking only this bracket. Minimum power is d square and maximum power is d4 of this bracket. Next bracket have minimum power is d6 and d cube and maximum power is d6. So we write only this bracket. So after opening this, 1 upon 2 x square and 1 minus sign. So this minus and this plus. Okay, next this minus. So other term we are not taking, higher degree, higher power we are not taking here because this is x square. Differentiation of x square, d of x square is 2x, d square of x square is 2, d cube of x square is 0. So higher term we neglected here. So I am writing here x square and here d square x square plus 3d x square 3d x square and upon 2 here upon 2. Next minus sign, we write here only 9d square by 4. Here is plus sign 9d square by 4. A plus b का whole square, a square plus b square plus 2ab. So 9d square by 4 and x square. Next term are all 0. Other all terms are 0 here. All terms are 0. So we write here 1 upon 2 x square. Now differentiating here 2 times. D square of x square is 2 and plus d of x square plus 3 into 2x and upon 2 and plus d square of x square 9 into 2 upon 4. Only this. So now here I3 is equal to, this is pi of third function. So we write here this 2 cancel and this 2 cancel. So here 1 upon 2 and here x square and here this 2 cancel. So here 1 plus 3x in bracket minus 1 plus 3x and here is plus 9y2. Okay. Now taking LCM. So 1 by 4 here. So 2x square and minus 1 minus 2 minus 6x and plus 9. Now this equal to 1 upon 4 and here 2x square and minus 6x and plus 7. This is pi. This is equation 15. This is I3. After adding I1 plus I2 plus I3, we get complete solution. Now complete pi equal to I1 plus I2, pi of I1, pi of I1 plus pi of I2 plus pi of I3. So now pi of 1 is this 1 upon 10, 3 cos 2x plus 3, 1 upon 10 and in bracket 3 cos 2x plus 3 minus, this is minus common and plus here 1 upon 10 sine. So this is sine 3 sine 2x plus 3 and plus cos 2x plus 3. This is total answer of I1 and plus I2. What is I2? I2 is this plus 1 upon 3 e to the power x I3 plus I3. I3 is equation 15. So 1 by 4 2x square minus 6x plus 7. This is total pi. Now complete solution is y is equal to CF plus pi. So CF is C1 e to the power minus 2x plus C2 e to the power minus x and plus this equal to CF C1 e to the power minus 2x plus C2 e to the power minus x and plus 1 upon 10 here 3 sine 2x plus 3 plus cos 2x plus 3 and plus 1 upon 3, here is bracket small, and plus 1 upon 3 e to the power x and plus 1 upon 4, here 2x square minus 6x and plus 7. Okay. So this is the complete solution of question 1. This is the complete solution. This is the required solution of problem 1. Okay. Y is equal to CF plus PI. Okay. First of all, we find here CF and then we find PI. CF plus PI is complete solution of the problem. This is CF, C1 e to the power minus 2x plus C2 e to the power minus x plus 1 upon 10, 3 sine 2x plus 3 plus cos 2x plus 3 plus 1 upon 3 e to the power x plus 1 by 4, 2x square minus 6x plus 7. Okay. Now I want to solve next problem second. Problem second is solve the differential equation d2y over dx2 plus y equal to sin x into sin 2x plus e to the power x into x square. So here solution d2 by over dx2 plus y equal to sin x into sin 2x plus e to the power x into x square. This is equation 1. What dy over dx is dy. So I am writing here, and d2y over dx2 is d square y. So you are writing here d square y and plus y equal to sin x into sin 2x plus e to the power x into x square. This is equation 2. This equation is 1. This equation is 1. Okay, this 2. So now y is taking common. Y is taking common. So d square plus 1 into y is equal to sin x into sin 2x and plus e to the power x into x square. This equation is 3. Here putting sin 2x into sin x. Formula 2 sin A sin B. 2 cos A cos B, 2 sin A sin B. Here we apply formula 2 sin A and into sin B. Cos A minus B minus cos A plus B. So now what is this? We apply value of this. So sin 2x and into sin x sin 2x into sin x, this equal to 1 upon 2 cos 2x minus x minus cos 2x plus x. Okay, so we write here 1 upon 2 in bracket cos x minus cos 3x. This is the value of sin 2x into sin x. Sin 2x into sin x. This is the value of this. This value putting in our question. Then our question is d square. This equation is 4. D square plus 1 into y is equal to, here 1 upon 2 cos x minus cos 3x and plus e to the power x into x square. This equation is 5. In equation 5, in equation 5, putting RHS equal to 0. So d square plus 1 into y is equal to 0. This equation 6. Now auxiliary form of 6, putting d equal to m and removing y from 6. Then we get m square plus 1 equal to 0. This equation 7. This is an auxiliary form of 6. This is an auxiliary form of 6. This is an auxiliary form of 6. So here m square equal to plus 1 equal to 0, m square equal to minus 1, m square equal to I square, and m equal to plus minus I. So here m equal to plus minus I. So M equal to alpha plus minus I beta. Alpha is 0 and beta is 1. So alpha is 0 and beta is 1. Now formula for CF CF is equal to e to the power alpha x in bracket cos beta x C1 cos beta x plus C2 sin beta x. This is formula for CF. So CF is equal to e to the power alpha is 0x, C1 cos beta is 1, alpha and beta is 1, so cos x plus C2 sin x. Okay. So now C1 cos x and plus C2 sin x. This is complementary function. This is complete complementary function of problem 1. So this equation is 7, 8. This is the 8 and this is 9 and this 10. Okay, complete solution is 10. Now Pi, particular integral. This equal to 1 upon Fd into Q. This is basic formula. Basic formula. So here Fd is d square plus 1. And Q, what is Q? Q is sin x. What is Q? Q is 1 upon 2 cos x minus cos 2x and plus e to the power x into x square. Okay. So this is equation 10. Now finding Pi of 10. So Pi is equal to 1 upon d square plus 1 into 1 upon 2 cos x and minus d square plus 1 into 1 upon 2 cos 3x and plus d square plus 1 and e to the power x into x square. Okay. So now this is I1, this is I2 and this is I3. So Pi of I1. Pi means I1. I1. What is Pi of I1? We write here 1 upon d square plus 1. Only this term taken here. First of all, we find out particular integral of first term. D square plus 1 into 1 upon 2 into cos x. Okay. So here we apply formula. What is formula of Pi? 1 upon d square plus a square sin ax. So answer of this is minus x upon 2a cos ax. Okay. Next 1 upon d square plus a square into cos ax this equal to x upon 2a sin ax. This is general formula. We have proved here formula this. We have discussed about this formula in theory classes in detail. So you check how we can find the result this. So here is cos, we apply second formula. So here is A is 1. In our question, here is A is 1. Here A is 1. So we write answer 1 upon I1 equal to, direct we apply this formula, cos is this. So here x upon 2a, a is 1, 2 and cos x. This is the answer of I1. Okay, this is equation number 11. This is equation number 11. Now next result is I2. I2 is Pi is equal to 1 upon d square plus 1 into cos 3x. Here a is 3. So putting d square equal to minus a square. So d square equal to minus 3 ka square means minus 9. Putting minus 9. This is the formula. So this is putting here d square equal to minus 9 plus 1 and cos 3x. So this is minus 1 by 8 and cos 3x. This is answer 12. This is Pi is 12. 11 and 12. Now last answer is I3. I3 is equal to Pi 1 upon d square plus 1 e to the power x into x square. Now this equal to here product of exponential function and algebraic function. In third Pi, in I3, in Q, in our question, in third function, there are two functions in multiply. First is exponential function e to the power x, other is algebraic function. So exponential function taking left side of whole Pi and putting d equal to d plus a. A is 1 here. Comparing to e to the power x to e to the power ax. So here a is 1. So here d plus 1 ka whole square and plus 1. Only single function x square is there. This function taking this side. Okay. This function taking this side here. This exponential function goes to left hand side. So e to the power x. Now then Pi equal to I3, this equal to e to the power x d plus 1 ka whole square. So d square plus 1 plus 2d and plus 1. D plus 1 ka whole square. I am opening this d plus 1 ka whole square. D square plus 1 plus 2d plus 1. So we write here in x square. Now this equal to e to the power x. Here d square plus 2d and plus 2 x square. So minimum power of d taking common. It means here d square, here d to the power 1, here d to the power 0. So here constant taking common. Then we write here e to the power x upon 2. And this result here is 1. And here is d square plus 2d and upon 2 whole to the power minus 1 into x square. Now open here binomial e to the power x upon 2. Making here binomial theorem 1 plus x to the power minus 1. So 1 minus d square and plus 2d upon 2 and plus d square plus 2d upon 2 ka whole square and minus, and this goes up to infinite. This is x square. So here only this bracket we are taking. Next bracket is 0. So I am writing here e to the power x by 2 and in bracket multiply by x square. X square minus here d square by 2x square and minus 2d by 2x square, and in this bracket we are taking only d square because d of x is 1, d square of x is 0, d cube d of x square is 2x, d square of x square is 2, and d cube of x square is 0. We apply this formula. D cube, 3 times differential of x square is 0, 2 times differential of x square is 2, and 1 time differential of x square is 2x. So d cube and her terms here neglected. Only d and d square we are taking here, derivatives. First derivative and second derivative. Other higher derivative are 0. So in this result, only 4d square by 4 plus 4d square by 4 into x square. This closed. Other functions are plus 4d square by 4 and x square and plus 0 plus 0. Other terms are this one. All terms are 0. So here this equal to e to the power x upon 2 in bracket x square minus here x d square x square. D square x square means only 2 upon 2. And dx square means minus 2 into 2x upon 2. And here it plus 4 is cancelled. D square x square means 2 plus 2. This bracket cancel. 2 into 2x and 2 upon 2 and x square. So finally pi is I3. Pi equal to. What is I3? Pi is this is I3. This is I3. This is also I3. Now I3 is equal to here e to the power x upon 2 and in bracket. What is in bracket here? This 2 is cancelled. This 2 is cancelled. So here x square minus 2x plus 1. We get here x square minus 2x plus 1. This equation number, this 12 and 13. This is 13. Now complete pi equal to I1 plus I2 plus I3. Pi of I1, pi of I2, pi of I3. Pi of I1 plus pi of I2 and plus pi of I3. Adding, then we get answer. This CF is equal to, this is not pi, total pi, yes. Pi is equal to, adding first pi from equation 11. This is equation 11. This is I1. In 11 is I1, x by 2 cos x. So we write here x by 2 cos x. And next equation, this 12 minus 1 by 8 cos 3x. This is I2. This is I2. I2 is this. This is I1. This is I1. This is I2. Minus 1 by 8 cos 3x. Minus 1 by 8 cos 3x. And plus I3. I3 e to the power x by 2 in bracket x square, this one, this equation 13, this one 13, x square minus 2x plus 1. This is complete PI. Complete PI this. Now y is equal to CF plus PI. Adding complementary function and particular integral. Then we write here y is equal to C1 is C1 cos x, C1 cos x plus C2 sin x, and plus xy2 cos x minus 1 by 8 cos 3x and plus e to the power xy2 x square minus 2x plus 1. Okay, this is complete solution. Y equal to CF plus PI. So here we have discussed problem 2 in detail. Now next problem 3. This is also very easy problem and we can solve here solution. This is also differential equation of second order with constant coefficient. So we write here d2y over dx2 and plus 5 dy over dx plus 6y is equal to sin 4x into sin x. Okay, this is equation 1. Now this is our question and this is equation 1. So here we know that 2 sin A sin B formula. This formula is cos A minus B minus cos A plus B. This formula, okay. So here sin A into sin B, this equal to 1 upon 2 and cos A minus B minus cos A plus B. This is the 10th class formula and very easy. We apply here because here is multiply in sin 4x into sin x. Multiple of two functions in trigonometry. How we can add? We want to write in addition form. In any place, in particular integral, the trigonometry function are in multiply. Then we want to write in addition form. So we apply this formula. Now sin 4x and into sin x, this equal to be applied here to cos A minus B, 4x minus x and minus cos 4x plus x. So we write here 1 upon 2 cos 3x and minus cos 5x. Okay, we can write this. So this equation 1 and this equation 2. Now our question is d square plus 3d and plus 2 into y is equal to 1 upon 2 cos 3x minus cos 5x. This is equation 3. So first we will find CF. So putting RHS equal to 0. Then we get here d square plus 3d, 3 naught, 5 and 6. Here is 5 and here is 6. Okay. So here is 5 and plus 6 into y is equal to 0. This is equation number 4. Now finding an auxiliary form of 4, finding auxiliary form of 4, putting d equal to m and removing by from 4. Then we get m square plus 5m and plus 6 equal to 0. This is equation 5. So now after factorizing of 5, after factorizing of 5, m square plus 3m plus 2m plus 6 equal to 0. M is common, m plus 3 plus 2 common, m plus 3 equal to 0. So m plus 3 and m plus 2, this equal to 0. So m equal to here minus 3 and minus 2. So m equal to m1, this equal to minus 3, and m equal to m2, this equal to minus 2. So here roots are different. Here roots are different. So we apply formula for CF. C1 e to the power m1x plus C2 e to the power m2x. So C1 e to the power minus 3x and C2 e to the power minus 2x. This is CF. This is complementary function of given question. So this is equation 7. Now Pi equal to 1 upon Fd into Q. This is basic formula of given question Fdi into Q. So what is Fd? Pi equal to 1 upon Fd. Fd is d square plus 5d and plus 6 into Q. What is Q? Q is 1 upon 2 cos 3x minus cos 5x. Okay. So now Pi is equal to here 1 upon 2 1 upon d square plus 5d and plus 6 into cos 3x minus 1 upon 2 d square plus 5d and plus 6 into cos 5x. So Pi is equal to this I1 and minus this I2. I1 minus I2. This is I1, Pi of I1 and minus Pi of I2. This is equation 8. Now we find out the Pi of I1 and Pi of I2. Then subtracting I1 minus I2. So here now second part. Here Pi of I1. So this is 1 upon 2 and here d square plus 5d and plus 6 into cos 3x. Okay, cos 3x. So here we have already discussed putting d square equal to minus a square equal to minus 3 square equal to minus 9. Equal to minus 9. So we write here this equal to 1 upon 2 in bracket d square means minus 9 and plus 5d plus 6 and into cos 3x. Cos 3x. So this equal to 1 upon 2. Here denominator में 5d plus 3. 5d plus 3. Now conjugate bracket multiply here. 5d minus 3 upon 5d minus 3 into cos 3x. 1 upon 2. Here 5d minus 3 upon 25d square minus 9 and cos 3x. Okay. So cos 3x taking inside the bracket. Then we get here 1 upon 2 5d cos x cos 3x and minus 3 cos 3x and upon putting d square equal to 9. Here putting d square equal to 9 minus 9. Minus 9. So here is 25 into minus 9 and plus minus 9. So this equal to here 1 upon 2 pi of I1. This equal to 1 upon 2. Now differentiating this. Cos ka minus sign. So here is 5 into minus 3 cos sin 3x and minus 3 cos 3x and upon 225 minus 9. So now pi of I1, this is 34 minus 234 minus 1 upon 234 and here 1 upon 2 also into multiply 1 upon 2 and in bracket is 5 3 is 15. 3 is common here and minus also common. So here is minus common and 3 common. So here what happened here? 5 sin 3x 5 sin 3x and plus cos 3x. Okay, cos 3x. Now 3 cancel by this. 3 7 is 21, 3 8 is 24. So multiply by 2, then this equal to 2 8 is 16, minus plus 1 upon 16, 2 7 is 14 means 50. And here 5 sin 3x plus cos 3x. This is pi of I1. This equation is 9. This is 9 equation. Now pi of I2 is equal to, what is I2? I2 is cos 5x. I1 and I2. I2 is 1 upon 2. I2 is minus 1 upon 2 and 1 upon d square plus 5d and plus 6 into cos 5x. So now putting d square equal to minus 25. So this result is minus 1 upon 2 minus 25 plus 5d and plus 6 into cos 5x. Now this equal to minus 1 upon 2, and here 5d 25 plus 6 minus 21. Multiply its 5d plus 21, 5d and 21, and 5d minus 21 into cos 5x. Now this equal to minus 1 upon 2, and this equal to now 5 cos 5x d 5x and plus 21 cos 5x and upon here 25d square cos d square minus 21 20 is 441. Okay, so here and d square putting minus a square. So putting here d square equal to minus 25. So this answer I2 is equal to 5d. 5d means minus 5 sine 5x. So here minus 5 means 25. 25 sine 5x, and here plus 21 cos 5x, and upon here minus 25. So here minus 25 d square means 25 into minus 25 and minus 441. Okay, so I2 is equal to here minus 25 sine 5x and plus 21 cos 5x and upon minus 625 minus 441. Okay, so this is I2. Final PI here I1 plus I2, and complete solution y is equal to CF plus PI. This is complete solution. Okay, now last problem of this question is I am putting here, this is very easy problem. Solution d cube minus 4d square minus d plus 4 and into y is equal to e to the power 3x and cos 2x. This is question 1. Putting RHS equal to 0 to find CF of 1. Then d cube minus 4d square minus d plus 4 into y is equal to 0. This equation 2. Putting d equal to m and removing y. D equal to m and removing y from 2. Then we get an auxiliary form of 2, that is m square minus 4m square m cube minus 4m square and plus minus m plus 4 equal to 0. Now factorizing m equal to minus 1, m plus 1, 1 minus 4, 1. 1 means m minus 1 is a factor of 3. This equation 3. M equal to minus 1 is a factor of equation 3. Now finding other factor. So m minus 3 m minus 3 here. Here is m cube minus 4m square minus m plus 4. So divide by this m minus 1. After dividing here, we get here. So m square is here. M cube minus m square. Minus plus, this cancel. Here is minus 3m square and minus m. So here is minus 3m. So minus 3m square and plus 3m. This plus and this minus. So here is minus 4m and plus 4. So taking here minus 4. So minus 4m and plus 4. So this cancel this after changing sign, and this result remainder is 0 here. Okay. So we get here m minus 1 n into m square minus 3m minus 4 equal to 0. So now factorizing this, m minus 1 here, m square minus 4m plus m minus 4 equal to 0. Now factorizing this, m minus 1 and here in bracket m common, m minus 4, m common here m minus 4 plus 1 common m minus 4. This equal to 0. So now m minus 1, m minus 4 and m plus 1 is equal to 0. So m equal to here 1, 4 minus 1 are roots. These are roots. So here CF is equal to C1 e to the power m1x plus C2 e to the power m2x and plus C3 e to the power m3x. There are three roots. So C1 e to the power x plus C2 e to the power 4x plus C3 e to the power minus x. This is CF. Okay. So this equation is 4. This is 4. Now Pi is equal to 1 upon d square minus 4d and plus 4d square minus d plus 4 minus d plus 4. D square minus 4d square minus d minus 4 plus 4. So now Pi equal to, we find out second part Pi, and here is e to the power, what is q? Q is e to the power 3x cos 2x, e to the power 3x into cos 2x. So exponential function taking this side, 1 upon d exponential function taking left hand side, e to the power 3x. Now d plus 3 का whole square minus 4 into d plus 3 का whole square and minus d plus 3 and plus 4. D plus 3 plus 4. Putting d equal to d plus 3. Here putting d equal to d plus 3 if exponential taking left side. And here is cos only 2x. So after opening this, e to the power 3x 1 upon. How we can open this? D plus 3 का whole cube. D plus 3 का whole square. D square plus 6d and plus 9. Now again d plus 1. So here d square plus 6d plus 9. D cube plus 6d square plus 9d. And plus d square plus 6d and plus 9. So here is d cube plus 6d square 7d square and 96d 15d plus 15d and plus 9 and minus d square, opening this, then minus 4d square minus 24d and plus minus 36 and here minus d minus 3 and plus 4. So here is cos 2x. Now e to the power 3x into 1 upon. Here d cube 7d square minus 4d square. 7 4 means 3d square. And here 15d and 24d minus 9d. Minus 9d and minus d. Minus 10d. Here is 25 minus 15 minus 10d. And here is 5 9 9 36. 39 minus 30 only. Here is minus 39 and minus plus 9 minus 30 and plus 4. Minus 30 plus 4 26. 26. 9 4 is 13. Here is 39. 13 and 39 26. Here is cos 2x. So now here pi is equal to e to the power 3x and into putting d square equal to minus 4. So putting here 1 upon d into minus 4. And next 3d square plus 3d square means minus 4. And next minus 10d, no change, minus 10d. And next minus 26. Here is cos 2x. Now this equal to e to the power 3x. And here is minus 4d. 1 upon minus 4d. d into minus 4. And 3 into minus 4 minus 10d. So here is minus 4d, minus 12, minus 10d and minus 26. And here is cos x 2x. So now here e to the power 3x and here is 1 upon. Here 10d minus is common. I am taking minus common. So here is 10d and 4d, 14d and 12 26 minus 36, 38, 38 and here is cos 2x. Clear? Making multiply here. 2 is common. Minus e to the power 3x and 2 is common. Taking minus common, so here is plus. 2 is common, so here is 1 upon 7d and minus plus 2 is common. 2 1 ja 2, 2 9 ja 18. And here is cos 2x. So conjugate bracket here multiply. Multiply by conjugate bracket. Here pi is equal to minus e to the power 3x upon 2 and equal to 7d minus 19 upon 7d plus 19 and into 7d plus minus 19 and into cos 2x. Okay. So now this equal to e to the power 3x upon 2 and here 7d cos 2x minus 19 cos 2x upon here 49d square and minus 19 9 361. So now e to the power minus e to the power 3x upon 2 and here differentiating this minus 14 sin 2x and minus 19 cos 2x. And here d square, putting d square equal to minus 4. So 49 into minus 4 and minus 361. Okay. So this is after simplifying we get complete This is complete pi. Now y is equal to CF plus pi. This is complete solution. After adding CF, y is equal to CF n plus pi. This equation pi equation number. This is equation number 4. And now this equation is 5. This is 5 equation. Adding 4 plus 5, we get complete solution. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.